Hello everyone, it's indeed inspiring to see you back again. This is tutorial 1 on Big Data series and the topic is Introduction to Big Data and Hadoop. Let's begin with it. So Big Data, as per the Gartner's definition, which was given, I believe, in near about 2000-2001, they say that big data is a term applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process within tolerable elapsed time. Let me simplify it. So it becomes sometimes very complex if you see definitions like this. So big data is basically if you have a laptop and you have a capacity of 1 TB, but you want to store data more than that. So is your laptop capable enough right now to store anything which is more than 1 TB? Obviously not. So you are facing big data situation. Now take the situation to a company level. If a company is having a storage capacity of 1000 terabytes of data and the data they are receiving every day, it is around 10 terabytes. So in very near future, after a month's time or after 2 months time, they are really going to face big issues because they don't have much capacity to store that data. Either they need to increase their capacity or they need to find out some reason so that they can wipe out data so early that they can store the new coming data, upcoming data. Are you getting this point? Let me give you another example, simple example. If you're sitting in a room and the room capacity is 10, then how many people can be accommodated? Obviously 10 people. If you have more than 10 people, you are facing big data situation if you treat people as data, right? So this is big data. It is situational. It depends from company to company's capability. For a company, a data may not be big data. For another company, it would be big data. Okay, so this is what is big data. Now, let me introduce you with Gartner's top 10 data analytics trends. Okay, 2021. So accelerating changes. This is the first category, operationalizing business value. Second, distributed everything. So in three categories, you can see here. The first one says smarter, responsible, scalable AI, composable data analytics. Data fabric is the foundation from big data to small to wide data, then operationalizing business value. We have extensive operational performance services. We have engineering decision intelligence. We have DNA as core business function. And then the third one, distributed everything, where we have graph relates everything, the rise of augmented consumers, and DNA again, data and analytics at edge. So these are the top trends in the 2021. So I recommend you go to the link and read about it more. Okay. Now, because we are getting into something where we are talking about distributed everything, so let me introduce what exactly is distributed computing. This will give you a fair idea that what if we talk about distributed everything, what does that mean? So distributed computing is a field of computer science that studies distributed systems. Okay. And now again, this is a technical definition. So let me draw something for you which will make very easy to understand. So let's say this is one CPU, this is another CPU, this is another CPU, and we have the fourth CPU here. So we have four CPUs. Let's say altogether, if I see one CPU is having 1 TB of hard disk. So 4 TB hard disk I will get if I will consume all of them. Okay. So 1 TB plus 1 TB this way. Okay. So 1 TB each. This is the configuration we have. All right. Now, if I have a mechanism which can connect all these machines, okay, first machine to second, second machine to third, third machine to fourth. So if I have such kind of mechanism, in that case, what will happen? I will be able to utilize 4 terabytes. Similar way, let's say one machine is contributing around 6 cores of the processor. Okay, and similar way, each of them are sharing 6 core each. So 6 plus 6. Okay, so 24 cores, CPU cores we have. If all of these machines can come together and process data, so don't you think you will be able to better manage and process your data in large size also? Obviously, yes. So here what we are doing, we are storing the data in a distributed fashion. We are processing the data in a distributed fashion. This is what we are doing here. Okay. Now let's go ahead. So a distributed system is a model in which components located on networked computer communicate and coordinate their actions by message passing. So you can see the connection which I have drawn here, right? Even in this diagram, you can see. So network, there will be some sort of network through which all the computers or CPUs or servers, whatever you call them, or nodes are connected, and they are able to communicate with each other. They're able to interact. They're able to uh, pass the messages. Okay, so some sort of message passing mechanism is there. The components interact with each other in order to achieve a common goal. So the primary thing is, for example, if you want to create a storage system, so you can go for own cloud, configure own cloud on multiple set of machines. So to the user, the own cloud will seems to be a single interface. User won't know that where your file is going to which server, right? So at the backend you have so many servers, but to the user it is only one single interface. So this is how you can connect multiple CPUs and use them for a common purpose. Let's move ahead and understand further what is the power of distributed computing if you want to process something. Suppose you have around 10 terabytes size of data set and you have a single node. Okay, you have a single node. With the help of single node, you want to scan it or process it. The speed is 50 MB per second. It will take 23 days to process it. 23 days. You can imagine. Okay, so I can't have so much of patience. 23 days. The same data, if you process in 1,000 node cluster, the same can be done with the 50 MB per speed. Okay, 33 minutes. Imagine you see, you just applied for some examination, you sat it, you have attempted, let's say it is subjective examination. By the time you are reaching your home, your results are out, right? So quick, right? So this is the power of distributed computing. Yes, I understand there are certain challenges also. The challenges related to hardware, because we have so many hardwares interconnected, right? So many hardware, so many machines, they are interconnected to each other. So hardware problems can be there. And when we are processing the data, so because the data is split into multiple machines, so we are not processing the data all together. Okay, it is split into different small chunks or portions, and then it is parallelly getting processed. So after getting processed, combining the results of the partial data sets, that again would be a challenge. Okay, but these challenges are really overcome by the tools and frameworks which we have today. Let's go ahead and try to understand. So when this situation arose, okay, handling large data set, that time Hadoop came as one sort solution. Okay, it emerged and it was so accepted, and today also it is being used in the industry. So this was a software which is still being used. Let me tell you a little bit about its journey. So it started with Hadoop 1.x, then 2.x, and today we have Hadoop 3.x in the industry. So Hadoop is Apache's, it comes under Apache. It actually started with the Yahoo. I'll tell you about that. So the definition of Hadoop is it is an open source software framework. Open source. Okay, so you need not to buy the license. Okay, you need not to pay for the license. It is open source for storing, processing, and analyzing. So it does storing, it processes, it analyzes for storing, processing, and analyzing massive amounts of multi-structured data in a distributed environment. Okay, massive, large amount. Okay, multi-structured. It can be structured, semi-structured, unstructured. So all kinds of data, variety of data in a distributed environment. Okay, distribute everything. So that is the kind of solution Hadoop gave. You can note one thing from this slide. It gives us two primary solutions. Okay, as of now, you can take this much. Distributed data processing. You can process the data in a distributed parallel manner, and distributed data storage. Okay, you can divide your data into smaller chunks and store it into different CPUs. This is the primary facility which Hadoop gives to us. Okay, moving further, there's a brief history. In 2002, it was a project called as Apache Nutch. So Apache Nutch was the project, and it was headed by Doug Cutting. Doug Cutting was the founder or father of Hadoop. This is how was a name given to Doug Cutting. Okay, so they were working on this project. It was a search engine, and there was again a search library called as Apache Lucene, which was being used at that time. So Apache Nutch and Apache Lucene 2002 projects. In 2003, they got a motivation from Google Distributed File System. Okay, like we have Google Drive, right? So at the back end, what happens? How Google manages out the data. So they have a GFS, Google Distributed File System or Google File System. So from that the motivation was taken. It was a white paper which they read and they got the motivation, and they designed Nutch Distributed File System, NDFS. And after that in 2015 they adopted MapReduce, again from Google's white paper they adopted MapReduce. So Nutch Distributed File System and MapReduce. So Nutch Distributed File System is storage service, and MapReduce is a kind of processing service, the way data will be processed. After that, in 2006 it went from Nuts to Hadoop. Okay, that's a fancy story, not fancy, a very funny story. Okay, Duck Cutting's son used to play with a toy elephant, a yellow colored toy elephant, and that kid used to call that elephant as Hadoop. So Duck Cutting basically picked the name from there, and this project was completely name was changed from Nuts to Hadoop. That is how it got the name of Hadoop. And after that, whatever tool you see, they are named on some sort of animal, insect, or some living being. After that, in 2008, it became the top level project in Apache because it was transferred from Yahoo to Apache. Okay, it started under Yahoo with a team, and it was transferred under Apache, and it broke the world record to sort terabytes of data. So this is how magnificent history of Hadoop, right? In very short, I have told you. All right. So then basically, let me tell you the architecture. As I told you that Apache Hadoop, it has got 1.x, 2.x, 3.x. Okay. This architecture is 2.x and 3.x high level architecture I'm telling you. So we have master nodes and slave nodes. So there is a master slave architecture. I'll be telling everything about that, okay, in upcoming series. So wait, have some patience for those series to come up. Okay. So it has got master slave architecture. Master components are name node, secondary name node, and resource manager. Slave components are data node and node manager, and a client services there. Solutions, it gives data storage solution. So name node, secondary name node, and data node, they help us in storage solution. Processing, resource manager and node manager. Okay, so they actually help in resource management, and resources help us to process the data. This is how it is. In case of Hadoop one, we had we did not have resource manager, we had job tracker, and we did not have node manager, we had task tracker. So in the channel you can find Hadoop one's video as well. You can have a look at them. So thanks a lot for watching this video. Wait for the upcoming tutorial. It will be really fun and a lot of learnings. Thank you. Thanks a lot. Do subscribe and like and share.